Now coming to the last part of the D and F block elements, there is a part 3. You can see we are having the differences. Before that I said the similarities. Now we are having the differences of lanthanides and actinides. You can see besides +3 oxidation state, lanthanides shows +2 as well as +4 oxidation state only in few cases. While actinides besides +3 oxidation state, they show +4, +5, +6, +7 also. Now, lanthanoids, most of the ions are colorless. Actinides, most of the ions are colored. Lanthanoids, they have less tendency towards complex formation. Actinoids, they have greater tendency towards complex formation. We have seen it. I have said you that actinoids are much more complex in nature than lanthanoids in terms of configuration. Lanthanoid compounds are less basic. Actinoid compounds are more basic. Lanthanoids do not form oxocations, but actinoids form oxocations. Lanthanoids, except promethium, they are non-radioactive, but actinoids are more radioactive. Just I was telling you, they are radioactive in nature. They are highly radioactive in nature. Except thorium and americium, they possess high densities and all are radioactive in nature. We can say that. Their magnetic properties can be explained easily, but in case of actinoids, their magnetic properties cannot be explained easily. It's not easy to explain the magnetic properties of of actinoids. We can say that. Then before going why KMnO4 cannot be used in presence of dilute HCl or HNO3 in transition, let me say you that the uses of lanthanoids and actinoids, if you see, then there is the MISH metals, MISCH metals containing 30 to 35% of cerium along with smaller quantities of other light lanthanoids are used as reducing agent in metallurgical purposes. Alright, there is MISH metals containing 30 to 35% of cerium along with smaller quantities of other light lanthanoids are used as reducing agents in metallurgical operations. Magnesium alloys containing about 30% MISH metal and 1% zirconium Zr are used for making parts of jet engines. Cerium salts are used in qualitative and quantitative analysis in dyeing cotton and in medicine. Cerium phosphate is used as a catalyst in petroleum industry. So these are some of the use of lanthanoids, I said you. Now actinoids, if you see the uses, thorium and its compounds are used in nuclear chemistry. Uranium and plutonium are used as fuels in atomic reactors. Thorium salts are used in medicines in the treatment of cancer. Uranium salts are used in glass industry, ceramic industry, textile industry and in medicines. So these are some of the use of actinoids which I told you. Now we will come on the screen, that is why KMnO4 cannot be used in presence of HCl or HNO3 in transition. Oxygen produced from KMnO4 plus HCl not only oxidizes, the reducing agent, but is also partly used for oxidation of HCl to chlorine. Alright, for that reason it's not used. HNO3 itself is an oxidizing agent and HNO3 also itself an oxidizing. See, KMnO4 oxidizing agent. With reaction with HCl, it reduces HCl to chlorine partly, and HNO3 itself acts as an oxidizing agent. So when the oxidation is going to take place, we'll never know whether it is by KMnO4 or with HNO3. Alright, so hence it is quite difficult to determine. Reason for the color of MnO4 minus ion is that Mn in MnO4 is in oxidation state of +7, which I have discussed with you with the D0 configuration. Hence color is not due to DD transition but due to charge transfer from oxygen to manganese, changing Mn from +7 to +6. Okay, this is all about your D and F block elements.